A logbook, 47 years old. The last entry is from a Tuesday in March 2023. Total airframe time, 11,847 hours. The aircraft is a Beechcraft Musketeer. It still flies twice a week out of a university training program in Illinois. The maintenance director looked at it in 1995 and used one word: bulletproof. That logbook is the answer to a question the aviation sales industry does not want buyers asking: which aircraft actually refuse to come apart when something goes wrong? 10 aircraft answer that question. Everyone costs less than a year of payments on a new aircraft. Some cost less than a used truck. The aircraft at the top of this list, a Cessna built 5 decades ago and still available for $58,000, has a documented fatal accident rate roughly half the industry average. Across 30 years of AOPA safety research and 38 years of university training fleet records, here is what the logbooks say. Logbooks are read by mechanics. The sales floor does not. Which aircraft on this list have you flown, or are you currently shopping for? Drop it in the comments. This is what Sky Ranch covers. Subscribe if you want the numbers the dealer skipped. Number 10. The Luscombe 8. In 1937, Donald Luscombe looked at every fabric and tube aircraft on the market and built an all-metal monocoque shell instead, the first of its kind in mass-produced light aviation. The result was a 2-seat side-by-side aircraft that cruised at 100 miles per hour with 65 horsepower, and it turned heads at every fly-in for a decade. The Luscombe gets walked past at every fly-in today because it looks rough. Corrosion is the one thing that kills a Luscombe. The structure does not fail on its own. The mechanism is the monocoque shell. Impact energy distributes across the entire airframe skin at once. There is no single load point where crash force concentrates, the way it does at welded joints in a tube and fabric aircraft. When the Luscombe hits something at low speed, the whole shell absorbs the load together. That was the engineering principle that made the design revolutionary in 1937. It still makes the aircraft structurally sound 87 years later. Luscombe produced 5,867. Approximately 1,665 still appear on the FAA registry. The most significant airworthiness directives were issued in the 1940s and the 1950s, and they have long been corrected. A clean example costs $22,000. Annual inspection costs in most markets are under $1,500. The aircraft that invented all-metal monocoque construction for light aviation is still flying in significant numbers. That is the engineering verdict. Number 9. The Stinson 108 Voyager. Walk up to a Stinson 108 on a ramp and it gives you everything. 4 seats, a fabric-covered steel tube fuselage, stalls that brake gently and recover on their own. The Stinson handles like a modern trainer. Stinson built it in 1946. The catch is the Franklin engine fitted to most examples. The Franklin crankcase has a documented cracking history. Before purchasing any Stinson 108, inspect the case carefully. Many examples have been converted to Lycoming or Continental power plants, which removes the problem entirely. Here is the mechanism that separates the Stinson 108 from every other 4-seat aircraft built in the post-war boom. Stinson engineers placed partial leading-edge wing slots along the outer wing panels. Those slots maintain aileron control even at full stall angles of attack. At the exact moment a stalling aircraft loses roll authority and enters a spin, the Stinson's ailerons keep working. Stinson built that feature into the wing specifically because stall and spin accidents were killing more post-war pilots than any other failure mode. No other 4-seat aircraft from the same era matched them. Stinson produced 5,260 Model 108s between 1946 and 1950. In 1992, the FAA documented 2,088 still on the US registry. 40% of the original production still airworthy after 4 decades. Used examples start at $28,000. Stinson built this aircraft to defeat the accident that kills the most pilots. The aircraft kept flying 75 more years without its manufacturer. Number 8. The Aeronca 7AC Champion, the Aeronca. The 7AC Champion did something no aircraft had done before it. It made Piper J3 Cub pilots admit the competition got something right. Designer Ray Hermes studied every weakness in the Cub and removed them. Better trim system. Oleo struts instead of bungees. The result flew in May 1944 and changed the training aircraft market before the war ended. The catch, 3 years of production from 1945 to 1948, then gone. 7,200 aircraft abandoned by their manufacturer. The mechanism is why 7,200 aircraft are still here. The Champ's fuselage is a welded steel tube cage with a triangular cross-section, a design tracing back to the Aeronca C2 of the late 1920s. When the aircraft hits the ground hard, the fabric covering tears and absorbs energy. The steel cage holds. The occupant space survives, under $25,000 on the current used market. Annual inspections, some owners report, under $1,000. Fabric replacement runs $8,000 to $12,000 and adds another decade to the airframe. The tube does not break. It bends. Bending is what keeps the pilot alive. 3 aircraft no longer in production. The next 4 have been in plain sight all along, in flight school fleets, in university hangars, in logbooks that mechanics read and buyers skip. Number 7. The Beechcraft Musketeer and Sundowner. Beech introduced the Musketeer in 1962 to give working pilots the quality of a scaled-down bonanza at a price that competed with the Cherokee and the 172. The result was a 4-seat low-wing aircraft with a wider cabin than either competitor. Beechcraft's manufacturing tolerances applied throughout. The catch is the landing. The Musketeer family demands precise speed control on final approach. Get it wrong, and the wide main gear, the same gear designed for crosswind tolerance, will demonstrate exactly what happened. That wide stance is the mechanism. Beech engineered the main gear for sideload absorption in the training environment. The geometry handles crosswind arrivals that would put a narrower tracked aircraft into a ground loop and redirects that energy into the structure rather than the rollout. The University of Illinois Institute of Aviation ran 19 Musketeer and Sport variants as primary trainers. 2 aircraft in the fleet exceeded 10,000 hours. 1 exceeded 12,000. Ted Horvat, the maintenance director, described the airframe in 1995 with one word: bulletproof. Beechcraft built the airframe to absorb training duty at that scale. Beechcraft produced 2,331 Model 23s between 1962 and 1983. Used examples range from $20,000 to $55,000 depending on condition. B-23 and C-23 variants carry Aerobatic certification in the correct configuration. Beech built this to beat the Cherokee. The Musketeer outlasted Beechcraft's entire light aircraft division by 40 years. That is the scorecard. Number 6. The Citabria, American Champion 7GCBC. For a window in the early 1960s, the Citabria was the only certificated aerobatic aircraft a working pilot could afford. Loops, rolls, Immelmanns, hammerheads, all legal in the standard factory configuration. Champion Aircraft flew the prototype in May 1964 and built something the market had no category for, an aerobatic-capable aircraft at a personal touring price. The catch is the tailwheel. On the ground, the Citabria's center of gravity sits behind the main gear. Let attention drift on rollout, and the aircraft corrects that immediately. The mechanism is the certification itself. The Citabria 7GCBC is rated to positive 6G and negative 3G at gross weight. Champion designed that rating for intentional aerobatic stress at full power. A hard-off airport forced landing generating 3 to 4G of impact force hits a structure engineered to handle twice that load as a routine maneuver. The steel tube airframe, descending directly from the Aeronca Champ, absorbs the load that the aerobatic certification made standard. The pilot does not absorb it. American Champion still builds Citabrias. Used examples from the 1970s and the 1980s are around $40,000. The structure, certified for intentional aerobatics, absorbs the emergency landing nobody planned. That is the arithmetic. Number 5. The Grumman AA-5 Tiger and Cheetah. Roy Lopresti took the AA-5 Traveler and produced the fastest fixed-gear four-seater of its era. The Tiger cruises at 139 knots on 180 horsepower. The Cheetah runs 125 knots on 150 horsepower. The catch is the 1974 to 1975 production run. Grumman used an improper bonding agent in all AA-5 series aircraft built between April 1974 and December 1975. Factory workers called it Purple Passion. In-flight delamination occurred in at least one aircraft. No accident resulted. The FAA issued an airworthiness directive in 1976 requiring rivets along all bond lines. Any Tiger with a serial number below approximately 125 requires specific inspection before purchase. The bonded aluminum construction is the mechanism. Load distributes across the entire panel surface, rather than concentrating at individual fastener points. A structure without discrete load concentrations does not develop discrete failure points. Grumman identified the defect, issued the fix, and built an aircraft that aviation consumer described with 3 words: nothing ever breaks. The total production was 1,323 AA-5B Tigers and 900 AA-5A Cheetahs. The used market ranges from $35,000 to $80,000 depending on condition and avionics. Grumman got it wrong. They caught it. The fixed version has no recorded structural failures. Number 4. The Cessna 150 and 152. More pilots learned to fly in a Cessna 150 or 152 than in any other aircraft in history. The training market selected it for 27 consecutive years of production for one reason: it let students survive their mistakes while they learned not to make them. The catch is the accident database. Thousands of NTSB entries. Read them. Of 100 recent Cessna, 150, and 152 accidents reviewed by Aviation Consumer, 36% were landing-related and fewer than 20% were fatal. The aircraft does not protect pilots from bad decisions at cruise altitude. At low speed, the structure does its job consistently. The mechanism is the relationship between stall speed and structural tolerance. The Cessna 150 stalls at approximately 40 knots clean. A forced landing at 50 knots generates a fraction of the impact energy of a forced landing at 80 knots. The airframe absorbs the energy that the slow stall speed did not create in the first place. Cessna added shoulder harnesses as standard equipment before the FAA required them. Aviation Safety magazine documented the fatal accident rate as well below the single-engine average, attributed directly to the slow-speed design and the structural over-engineering for training duty. Cessna produced 23,000 Model 150s and 7,500 Model 152s between 1958 and 1985. In the used market, prices range from $15,000 to $40,000. Count the fatal entries in the NTSB database. Show that number to the dealer. The pattern across all 7 aircraft is identical. Engineers designed each one for the environment where pilots fail. Each one documents survivability numbers the aviation sales chain omits. The Purdue University study of general aviation accident records confirmed this directly. Aircraft built between 1970 and 1984 show no statistically significant difference in malfunction-related accident rates compared to aircraft built between 2000 and 2014. The rate for older aircraft is 2.73 per 100,000 hours. For newer aircraft, it is 2.63 per 100,000 hours. The difference is 0.1 per 100,000 hours. The aviation market prices that 0.1 difference at approximately $400,000. Which part surprises you more, the Purdue data, or that nobody in the sales room quoted it to you? 7 down, 3 left. The next aircraft on this list have names every pilot already knows. The safety data behind them come from 30 years of AOPA accident research and documented fleet records, and the aviation press has not put that in a headline since 1999. Number 3. The Cessna 182 Skylane. The 182 is what the 172 grew up to become. 230 horsepower, 4 seats, 800 pounds of useful load, a range of 970 miles with reserve. The Skylane does everything the 172 does at a higher ceiling, a longer range, and a payload that accommodates 4 adults with bags. The aviation press calls the 182 boring. Instrument pilots want the retractable. Cross-country pilots want the turboprop. The 182 sits in the middle and outlives them both. Higher gross weight certification means heavier primary structure from the factory, that is, the mechanism. The Continental 0470 engine runs to a 1,500-hour time between overhauls and routinely goes past it without incident. The Cessna high-wing stall geometry scales intact from the 172, the gentle stall brake, the roll tendency that gives recovery time, all of it carries into the heavier airframe. The AOPA Air Safety Foundation studied 1,314 Cessna 182 accidents from 1983 to 1999 and compared them against a group including the AA5, the Cherokee, and the Cardinal. 72% of Skylane accidents resulted in minor injuries or less. The comparison group was 66%. 9 percentage points of survivability across 1,314 documented events. On the used market, prices start from $40,000 for early 1960s examples. Approximately 13,000 appear on the FAA registry. 9 survivability points across 1,314 accidents. Write that number on the back of the brochure you were handed. Number 2. The Piper PA-28 Cherokee. Low wing, 4 seats, 1 fuel tank per side, switched in flight. The Cherokee handles. Honestly, it responds where expected, signals clearly when something is wrong, and offers no surprises in the regime where most accidents happen. Aviation forums have called it basic for 50 years. The wing spar runs straight through the fuselage from wingtip to wingtip, continuous and uninterrupted. That is the mechanism. In a rollover or inverted ground impact, the spar becomes the primary structural member protecting the occupant space. There is no wing root joint to fail under load. The same spar that holds the wings in cruise redistributes crash energy laterally into the fuselage rather than transmitting it into the cabin. Researcher Ron Wanttaja analyzed general aviation accident data from 2001 through 2010 and corrected both the Cherokee and Cessna 172 rates for fleet size. The Cherokee's overall accident rate came out 50% lower than the 172, not the fatal rate. The total accident rate, meaning every landing excursion, gear collapse, and runway overrun, across a full decade of documented events. PA-28 180 from $30,000 used. PA-28 to 161 Warrior from $65,000 for clean examples. Same price range, half the odds. The sales floor never said that. Number 1. The Cessna 172 Skyhawk. Cessna has produced 44,000 since 1956. It is the most produced aircraft in the history of aviation. Every safety benchmark in general aviation is measured against it. No aircraft on this list, or anywhere in the piston general aviation fleet, has generated more documented safety data across more flight hours than the Cessna 172. A new Cessna 172 SP costs $459,000. A 1978 Cessna 172N costs $58,000. After a decade of fleet size corrected accident data and 30 years of AOPA safety records, one study defines the question. The Purdue University study compared malfunction-related accident rates for aircraft built in the 1970s and the 1980s versus aircraft built after 2000. Older aircraft, 2.73 per 100,000 hours. Newer aircraft, 2.63 per 100,000 hours. Purdue documented the statistical difference as not significant. The price difference between those two Cessna 172s is $401,000. The AOPA Air Safety Foundation documented the Cessna 172's fatal accident rate in the 1990s at 0.56 per 100,000 hours. The general aviation industry average in the same period was 1.2 to 1.4, approximately half the industry average, calculated from documented accident records across the entire registered fleet. The mechanism is the design geometry: high wing with stable dihedral, full-span ailerons, stall speed of approximately 40 knots with full flaps. When the Skyhawk stalls, it brakes gently and without rolling off. The pilot gets recovery time that a sharper stall does not provide. Cessna locked that geometry into the first production model in 1956 and has not changed it. The FAA has access to the Purdue data. Every dealer who shows a new Cessna 172 SP specification sheet has access to the AOPA safety review. That $401,000 gap did not come up. 10 aircraft, 1 pattern. Every aircraft on this list came from an engineer solving for one environment: the training runway, the off-airport forced landing, the stall at 500 feet with no altitude left. The engineers behind these airframes were not designing for the pilot who executes every procedure correctly. They were designing for the student who gets it wrong, because the training and backcountry markets demanded survival, not elegance. The safety record followed from that requirement. The Purdue malfunction data, the AOPA fatal accident rates, and a Musketeer with 12,000 hours in Illinois say the same thing. The safety engineering in general aviation was finished decades ago. The aircraft that carry it cost between $22,000 and $80,000. The aircraft the market calls the safe option costs $459,000. Flying one of these, or still letting a dealer quote you the glass panel as the safety upgrade? Drop the aircraft and the year below. Tell me which category your logbook is in, and whether you would make the same call again. Subscribe to Sky Ranch. The numbers the sales floor skipped are what we cover here.